So when we have two different groups, we have group star and dot. So G is mapped to G prime. If the operation of the first group opens the operation of the second group, that is file of a star b equals to file a dot file b, then file G mapped to G dot is called an homomorphism. We have type of homomorphism. We have the one-to-one. The one-to-one homomorphism is also known as monomorphism, while onto homomorphism is known as epimorphism. So on one-to-one plus onto homomorphism is called an isomorphism. Then homomorphism plus bijective homomorphism is called an automorphism. Now there is a difference between homomorphism and automorphism. Homomorphism deals with the same group, while automorphism have different groups. So G prime is known as the homomorphic image. G prime is known as what? Homomorphic image. Then there is this relationship between the kernel of an isomorphism. When we say the kernel of an isomorphism, it is referred to as K theta, K file. So we have K file to be isomorphism. It is a trivial subgroup. That is, when we say trivial subgroup, a group that is a group with only the identity element. So ker theta is G in G when we have file of G to be equals to E prime. So E prime is representing our identity element. So it is a trivial subgroup. So that's the relationship between homomorphism and kernel of file. So we have examples of homomorphism. A very good example of homomorphism is the group of matrices. The group of matrices is referred to as GL2R or simply GL2. So when you see GL2, where R is representing real numbers, because when we deal with matrices, we are referring to real numbers. So GL2 simply means the group of matrices. So let's check more. Let's get to more explanations on GL2. Now, as I said earlier, that the group of matrices is GL2R. Now, this simply means that this is a group. Why? Because we have the inverse and we have an identity element. So it simply means that group of matrices is also a group, but it is not an abelian group. So if you have AB cannot be equals to BA, so it is not an abelian group. So we have example 2. Example 2 is already given. I gave the expression earlier in the first two images that was displayed. So R star be the group of non-zero real numbers under multiplication. Then the kernel of the determinant mapping is SL2. How does this come in place? We have that GL2 is mapped to R star. What is R star? R star is simply the group of real numbers except from 0. So we know that GL2 is group of matrices 2 by 2 matrices. So file of A, if file of A is equals to the determinant of A, this simply means that file of A dot B. So file of A dot B equals to determinant of A times determinant of B. So this implies that, and this obeys the law of homomorphism. So this simply means that file is an homomorphism. Now we have another example. We have if file is mapped, before that the kernel of file equals to the group of matrices. If the determinant is 1, then we have SL2R. Then we have another example. a group mapped to the same group, the set of real numbers mapped to the set of real numbers except 0. So this simply means that for homomorphism, for automorphism, we usually have the same group. So this simply means that this is what an automorphism. So you should take the difference between an homomorphism and automorphism.